Hi, let's look at this problem real quick. And and this video is really gonna save your grades. Because the most common mistake students make for such kind of problems, when they see this function, they just start putting these values in it and think that that's it. But it's important to remember that we've been asked about velocity. So the problem is the displacement in meters of a particle moving in a straight line is given by the equation of motion. S is equal to 1 over t square, where t is measured in seconds. Find the velocity of the particle at times t is equal to a, 1, 2, and 3. So we are looking for rate of change here, which is derivative. And and in we have given this function for the equation of motion, which is S is equal to 1 over t square. And as a little reminder about the definition of derivative, as h approaches to 0, f of a plus h minus f of a by h. Okay, because we often have to plug in this into the function itself, so it's also handy to just you can do it on side first, as we to simplify this expression here. Either way is fine, however you guys like it. Okay, so the solution for this is, let's find the velocity of this particle at times t is equal to a first. Function okay, on side what I'm gonna do, I'm just gonna simplify my expressions right here. So f of a plus h is what? This is 1 over a plus h square, which is a plus b square formula we're gonna apply here. So a square plus h square plus 2 a h. And f of a is what? F of a is 1 over a square. Already. So let's just plug into this. F of a plus h is this, minus f of a is this. Divided by h. The most common mistakes majority of the students make is here. They find this a little bit confusing. The like why like there's multiples of divisions are going on. For example, this is example just to understand the idea what is going on here. Suppose this is what we have, right? Suppose something here as well. So this is one expression here divided by this part over here, and you can also write this down just to make it easy, for example, this expression, and you have to find the LCM of this, right? It would be 4 4, and then 2 times 2 is 4. This is 2 minus 1 which is 1 over 4 divided by 4. So you can also write this down as 4 divided by 1, right? It's not gonna hurt. It's same, it denotes the same idea that it is 4, just to simplify the expression, right? So it's easy to evaluate. And if you know, if there is something like this, you can always, if this is divided by this, the reverse would be multiplication of this expression. It would be like this. And this is exactly what we are doing in this problem as well. H over 1, the reverse of this, right? So what we have here is, just take the common factors here. This is going to be a square minus, this is going to be 2h divided by h. This whole expression is divided by h. So as I just mentioned here, right? If something is in dividend here and then over here, then this is just the reverse of is going to be multiplied. So this is going to be limit as h approaches to 0, and we are going to simplify this on the way. Minus a square minus h square minus times 2ah divided by h a square. Okay, now this is cancelling out, and we can take the common factor here. Okay, so next is what we are left with. We can take the negative h common here, right? And what we are left with, h minus plus h plus 2a, because positive times negative is negative, 2a times h divided by h a square plus h plus 2h. So h is going to be cancelled out here, and then what we have here is negative times h is negative h, negative times 2 is negative 2a. You can write either way. You can still have a negative out and with this expression, or either this one. However you guys find it easier or convenient. Okay, at the bottom we have is And as h approaches to 0, we can see this is gone. What we are left with is, okay, I can just plug in the values real quick. 0 minus 2a divided by a square plus 0 plus 2 times a times h, which is 0, is 0, right? So we are left with negative 2a divided by a square times a square is a to the 4, and 1a is going to be cancelled out with this. So the velocity of this function when t is equal to a is negative 2 divided by a cube meter per second. Oh, sorry, excuse. This is okay. And at the next stage, we can just simply plug in the values here. As we already have f of a is negative 2 over a cube meter per second. So you can already guess when t is equal to 1, of 1 is equal to negative 2 divided by 1 to the cube, which is also 1. So this is going to be negative 2 meter per second. When t is equal to 2, f of 2 is negative 2 divided by 2 to the cube. You can also write it down here this way, so it's easy, cancels out. We are left with negative 1 over 4 meter per second. T is equal to 3, f of 3 is equal to negative 2 over 3 to the cube, which is negative 2 over 3 times 3 times 3 is 27 meter per second. So here is your solution to this problem. I really hope this helps and makes more sense. I hope these tricks are helpful to you as well. So thank you so much for watching.